Hello everyone, today in this video we'll be discussing the super important questions of the Introduction to Civil Engineering subject first semester, and in this video all the questions which are going to be discussed are the super repeated ones including the numericals. So make sure you watch this video till the end and don't miss any of these questions. If you learn all of these questions it is sufficient for you to score more than 80% marks. And before starting, please do like and subscribe, it helps me make more videos like this. So without wasting any more time, let's get started. The first question from the module 1 is: explain the scope of civil engineering, list and explain different branches of civil engineering. Okay, so where all civil engineering is used and different branches of civil engineering will be discussing. Okay, so the first is surveying. Okay, what does surveying mean? Surveying means we'll be analyzing the area and we'll be making a map of it. Okay, topographical features will be taken into consideration and the location will be taken into consideration, what constructions can be done there. Okay, and the calculation, reduction and plotting of the survey data, all those things the civil engineering is used. Okay, so that is the first place. Second is in structural engineering. Structure means making a building or making a thing which will be like a bridge or something to support. Okay, so that all thing is called structural engineering. So studying the forces, how they are acting, and the type of material which is being used, and the position in which if the structure is balanced, that will be having the greatest balance. All those things come under structural engineering. Okay, so there also civil engineering is used. The third is geotechnical engineering. This is related to the soil and geographic of the place. Okay, how well is the soil, can it hold moisture, and what happens when an earthquake comes, all those things will be studied here. Okay, so the foundation and construction of the highway, pavement design of underground buildings and the earthen dam, for all of this geotechnical engineering is very much needed. Okay, next is hydraulic and water resource engineering. In this, the how the water resources are present and where if the dams are built will be giving us the most benefit, and how the water is to be stored, if excess water comes what is to be done, and how groundwater is to be utilized. All those things related to water is coming under the civil engineering. Okay, next is transportation engineering. It helps us identify the roadways, waterways and the airways, railways, all those things, how can we build so that the production and the consumption increases, the travel cost decreases. Okay, the travel happens more, and it's important to cover the remote areas, and what technologies we can apply, all those things come under the transportation engineering. Okay, next is the environmental engineering. It includes the ecosystem, the nature which provides the nature provides all the basic requirements such as food, air, water and shelter. So all those things which are present in the nature, air, water and land, to study that and what is the best way to use and protect it from the getting extinct, and the technique for the water collection, purification, simplify, all those things come under the environment engineering, for the environmental engineering. And next one is the construction planning and project management. So the plan is to be made before the construction, and how the project is going to go, who will be managing it, all those things come under the project management and construction planning. So it requires the knowledge, skills and the tools, techniques to required to meet the requirement. Okay, moving on to the next super important question: explain the plain, reinforced, and pre-stressed concrete. Okay, three types of concrete are there: plain, reinforced, and pre-stressed concrete. Explain ordinary RCC and PCC used in buildings. Okay, what is plain or ordinary concrete? Okay, it is one of the most commonly used concrete, and it is made up of the cement, sand, coarse aggregate, and water. Okay, it is used to construct the pavements and roads and buildings with high tensile strength is not required. It is also used in the construction of dams. Okay, it is strong under compression and weak under tension. That is the normal plain or ordinary concrete. Next is the reinforced concrete. Okay, in reinforced concrete there will be some differences. Here it will be included steel. Steel will be included in that. Okay, in a manner then two materials act together in resisting the forces. Okay, it is strong under compression and weak under tension. To increase the tensile strength, steel is embedded. Okay, so it is used in the structures like water tanks, dams, silos, bunkers and so on. Okay, and the economical cost is also negligible. The maintenance cost also is negligible. Okay, advantages is that it has a higher strength, production of concrete is low, versatile in the nature, it is durable. And disadvantage is that it is heavier like than others like steel, wood and glass. So concrete takes times to attain its full strength. That is one of the disadvantage. Okay, next is pre-stressed concrete. Okay, it is a form of concrete used in construction and it is pre-stressed or compressed during the production. Okay, so by the name itself we can understand it is compressed during the production in a manner that it strengthens against the tensile forces which will exist when in service. Okay, so it is compressed before using, and it can be used for longer spans, reduce structural thickness, and material saving compared with the simple reinforced structure. So its application includes in the construction of building, bridges, dams, and bunkers. Okay, moving on to the third super important question, we have write a note on structure steel and construction chemicals. Okay, what is structural steel? The iron has the carbon content 0.15 to 1.5% along with small percentage of manganese, sulfur, and phosphorus, and silica is known as steel. So what is steel? This much percent carbon along with manganese, sulfur, phosphorus, and silica. So it is used in making the shapes. It is broadly used in the carbon content such as mild steel, stainless steel, alloy steel, and so on. It is used in buildings, reinforcement structures, and columns, roof slab, beams, structuring, strengthening exterior walls, trusses, steel pipelines, tanks. Wherever the steel is required, all those places the structural steel is used. It has higher strength and low weight, durability, ductility, and corrosion resistance. Okay, now what are the construction chemicals? Okay, these are the chemicals that are used to create or stick other chemicals. Okay, masonry material like cement, concrete, and other construction materials at a time of construction to hold the materials together. The chemical which holds the different metals together is called as construction chemicals. Okay, so there are different types of the advantage is that workability, durability, strength, and efficiency is present. So different types of construction chemicals are concrete hardening, protective and decorative coating, concrete curing, epoxy coating, admixture, waterproof chemicals, etc. Okay. Now, write a short note on masonry walls, beams, slabs, and stairs. Okay. So, what is masonry walls? It is a structural unit in which the members of individual units are bonded together. Okay. These are the individual units. Those are bonded together. How they are bonded together? Using masonry. Okay. By a mortar. The masonry walls can be built by individual blocks such as stones, bricks, concrete, hollow concrete blocks, and cellular concrete cells. So, when many blocks are combined together, they form a wall. Right? They form a wall. So the types of masonry walls, there are different types of masonry walls. First is load bearing masonry wall. These will bear the load and which will carry the loads, and these are exposed to the atmosphere. Non-load bearing walls are the partition walls. They do not carry any load, it will just divide the rooms. Solid walls, masonry units close together with all joints filled with solid mortar. Reinforced walls is made of any type of brick that is reinforced with use of other building material like steel and fibers. In between, steel and fibers will be there to hold the bricks together. Okay, next is beam. Beam is nothing but a structural element that gives a support to a slab and carries load. That's all. It gives support and carries load. Okay, that is called as a beam. There are different beams used in building and structures, vertical and horizontal beams. Okay, so horizontal structural element can withstand vertical loads, and the beam transfers the load imposed on its length to its endpoints such as wall, columns, and foundations. So few different types of beams are simple support beam. On the ends it will be there and free to rotate. Fixed beam, which is supported on both the ends and restrained from the rotation. Overhanging, it extends behind supports on the ends. Continuous beam extends over more than two supports. Cantilever beam has fixed only one end and the other end is free to rotate like this. Okay, it can be rotated in this or this direction. Okay. Next is columns. Columns is a structural element that transmits the load or weight of the structure from top to bottom. Okay, what does a column do? From top to bottom, it transfers the load through axial compression. Okay, in other words, it is a compression member. Okay, for the purpose of wind or earthquake, columns are designed to resist lateral forces. So different types of columns are based on shapes. They can be different types of shapes or lengths or different types of loading like axially loaded, uniaxially eccentricity, based on type of reinforcement, tight, spiral, or composite, and so on. Okay. Next is a very interesting question. Stairs. What is a stair? Stair, we all know what it is, but the definition you need to write, right? So staircase is defined as sequence of steps that is provided to move from one floor to another floor. Okay. Apartments or rooms of a building in which stair is located is called as a staircase, and opening space is called as a stairway. Primary function of stair is to provide access from one floor to another floor. It provides a safe means of travel between floors and also suitable for in case fire happens. Okay. And parts of a stair, so stair has three parts: tread, riser, handrail. Okay, tread is an upper horizontal portion of a step on which the feet is placed. Riser is the vertical portion between the treads of a stair. So if this is a stair, okay, if this is a stair, Okay, just suppose that this is a stair, this is called as a tread, this is a riser, and handrail is the one where we'll be holding and will be going up, right? That is, this is called as a handrail. Support a blaster, it is a vertical member which supports the handrails. Okay, that is nothing but in the handrail it will be there, something will be there like this, right? This is the support blaster. Handrails run the total length of the staircase in a horizontal plane including landing. String or stringers are the sloping wooden members which supports the steps. Okay, so in between each of the steps there will be some wooden thing, right? That is called as a string or stringers. Okay, so these things you need to write for the stairs. Moving on, we have the next super important question. Explain about cement on mortar. Okay, what is cement? Cement is used in binding materials in constructions. Okay, it is manufactured by burning the mixture of lime, silica, and alumina with some mixtures at a very high temperature. Okay, then a gray color material is obtained that is called as a cement. Okay, there are many different types of cement such as Portland, Pozzola cement, rapid hardening cement, low heat cement. So these are used for the different purposes. There are different types of cements are there, and the heat which is generated when cement is mixed with water is called as heat of hydration. So these are the key points you will be writing. And to prepare a cement mortar, to prepare cement concrete, to prepare fireproof, thermal proof structures, to build chemical proof structure are some of the uses of cement. Okay. Now, what is mortar? Mortar is a homogeneous mixture of cement, sand, and water in some proportion. Okay, like 1:2, 1:3, 1:4, 1:6, etc. According to the work selected, with the concentration will be selected. Okay, and it hardens the stones, bricks, and concrete blocks together, and it are different types like cement mortar, lime mortar, gypsum mortar, and so on. Okay, and it is the most commonly used mortar nowadays. Okay. Next, the next important question is define foundation and write objectives of foundation with a neat diagram. Okay, what is a foundation? It is a substructure which transmits the loads of the superstructure to the ground surface. Okay, so before any building is made, the foundation is made. Okay, after a foundation only a building is made on top of that, right? So the foundation is important, right? The foundation supports the whole building. It is the lowest part of the structure with which the direct contact with the ground. It has two parts. The first one is substructure, which is the structural component constructed below the ground level. Superstructure are the are those structures or the components which are constructed above the ground level. Okay, so the function and objectives of the foundation are to distribute the total load, to support the structure, to give enough stability to stand, and to provide level surface for the masonry works, to provide structural safety against scouring due to flood, and to increase the stability of the strength of the building. Okay, so this is the diagrammatic representation of the same. This is the foundation. Okay, so this whole thing is called the foundation, and the burn brick memory is there, and the after this one the building will be made above that. Okay, moving on to the next communication, we have explained plinth, lintel, and chejja. Okay, so what is plinth, lintel, and chejja? The plinth is a part of a superstructure located between the ground level and the floor level, is known as plinth. Okay, between ground and the floor level, what is there is called as a plinth. Okay, the main function of the plinth is to distribute the load of the columns wall and use the foundation evenly. Okay, to distribute the load. It does not allow dampness. It gives strength and durability. It provides better aesthetic view, and it acts as a retaining wall or a barrier. Next is the lintel. Lintel is the horizontal member placed across an opening to support the portion of the structure above it. Okay, it is an opening that supports a structure above it. It's a sort of a beam which width will be equal to the width of the wall. The function of the lintel is just same of the arc or a beam. Okay, types of lintel: stone lintel can be there where the availability of stones are more. Wooden lintel is there, that is used in the olden days. Brick lintel and steel lintel is also there. Next is Chejja. Chejja is the extended portion of a thin slab above the door or the windows ventilators function. Okay, so it is present in the extended portion of the doors, windows, and ventilators. What is its function? It gives protection and opening space against rainwater and sunlight. Okay, it is called as a watershed. So different types of Chejja is also available. Okay. Moving on to the module 2, the first super important question is what is sustainable development goals, SDGs. Let's explain all the SDGs, most repeated question. Okay, this is the most repeated question of the module 2. Okay, so what is sustainable development goals? See, as we move towards progression and development, we'll be utilizing the resources of the world, right? So we once we utilize the resources of the world, we should ensure that it should not completely finish from the surface of the earth. Okay, we have to do it sustainably and without harming others and the environment. So some goals are set by 2030. It is planned to achieve all of those goals. There are 17 of those goals. We'll be discussing what are those ones. Okay, that is called as sustainable development goals. So first one is no poverty. It is planned to means there should be no poor people and human beings above the, and every human being should be above the poverty line. This is the first goal planned by the United Nations for sustainable development. Okay, and second is zero hunger. Okay, to achieve food security, everyone should be having food to eat. And third is good health and well-being. Fourth is quality education. Fifth is gender equality. Sixth is clean water and sanitation. Seventh is affordable and clean energy. Okay, almost 800 million people are having lack of access to electricity. That should be worked upon. Okay, and eighth one is decent work and economic growth. Due to a lot of unemployment, that should be ended, and everyone should be having an opportunity to work. Okay, and industry, innovation and infrastructure, that should be developed. Innovation should be encouraged. Reduced inequalities, inequality should be reduced. Sustainable cities and communities should be formed. Responsible consumption and production, there should be accountability as to what is getting consumed and produced. Climate action, life below water, the aquatic life should be conserved and sustainably, and life on land should be preserved and conserved sustainably. Peace, justice and strong institutions should be there for all of the aspects, and partnership for the goals, many people should join that and try to achieve the goals. Okay, write a short note on smart city, safe city, clean city, smart buildings. Okay, so smart city, what is a smart city? In smart city there will be there are technological features that can include in that has the outcome of energy conservation and environmental efficiencies. Okay, like street lights that dim when the roads are empty. Okay, or smart grid technologies. Okay, that can improve and maintain the power supplies. Okay, and management, waste management and sanitation via the internet enabled rubbish collection, bin and fleet management systems, automations. Okay, automating the things to happen on its own than manual. Okay, and enabling sensors to warn early before any flood, hurricane or droughts. Okay, smart buildings for the real time space management and structural health monitoring. If any building is going to fall, if there is any weak point in the building, that will be warned in the prior, so that action can be taken. All those things. Okay, that comes under the smart city. Adequate water supply and assured electricity supply, sanitation and efficient urban mobility and public transportation. Safe city is the one which is safe from the crime and terrorism, and from any natural calamities. If any calamities come, there should be departments to help that, and a public health and social service department should be there. And if some calamity comes or the earthquake and all comes, how can people be rescued safely? All those things will be present. That is a safe city. Okay, so the seven principles of safe cities: avoid urban sprawl, slow down the traffic, ensure main streets are safe for everyone, create dedicated space for the pedestrians, provide safe and connected network for cyclists, and ensure safe access to high quality public transport, use data to detect problem areas. Okay, third one is the clean city. India is the country that aims to clean up the streets, road and infrastructures of the Indian cities, small towns and rural areas. Okay, Swachh Bharat is one of the initiation that is going on for the by the with the aim of clean city. Okay, so to make the city clean and plant more trees and have fresh air, all those things come under the clean city. Okay, so the main aspects and the reasons why we need a clean city is because it looks beautiful and helps to keep environment healthy, and keeping the surroundings clean and filling it with greenery all around, you can enjoy pure and fresh air. By planting trees, you can reduce the pollutants in the air. Clean city means clean water which is free from toxins and contaminants, and not only preserves the environment but also tourists will be more there will be more people coming and visiting India. And green cities protect the environment in a unique way, and by reducing plastic and waste management, we're making world a better place to live for all human beings. Okay, so these are some of the reasons why we want clean city. And last one is smart buildings. What does smart building do? It uses advanced technologies and information communication technology to generate or create systems that can help the management and efficient management of the building efficiently, and provide services that help the public or the people living inside that building. Okay, so it uses to it collects the actionable data from the user devices, sensors, systems, and services on the premises, and constructed were essential for the smart city evolution buildings, and that can be more livable, workable. And there are four basic components. First one is the use of IoT, analytical software, user interface, and means of connectivity. The benefits of the smart building are measurement sensors. By use of the sensors, there can be many things automated. Predictive maintenance can be made more better than by using the equipments. And eco efficiency, there will be more efficiency if the things are automated. And comfort through HVAC, heating, ventilation and air conditioning helps keep the people happy and the building cooler. Okay. Next is explain urban waste air pollution or quality management, and explain about security systems. Okay, so in order to ensure clean air in urban areas, there are some plannings and departments which work on improving the quality of the air in the urban spaces. So urban air is a mixture of toxic gases and particulates, major source from the fossil fuels emissions that are reactive and govern local atmospheric chemistry. Okay, so there are some priorities and the rules which are designed to ensure that the air quality will be better. Okay, so all of the industries which are there which are producing the toxic gases, they are supposed to be following the policies so that the environment becomes more cleaner. And the most effective way in controlling air pollution is of using clean energy. Instead of using the fossil fuels energy, we can use the clean energy or electricity, so that the urban air pollution will be reduced. Okay, so the UAQM practices are specified to a country's need and requirement. And what is security system? It is a system which, by the name itself, we can understand that it will provide security to the people who are living inside the area. So a typical home security system includes a control panel with door and window sensors, motion sensors to detect who are coming and who are going, and having CCTV cameras and wireless and wide security cameras, so that people feel safer. Okay, that is security systems. Next is explain solid waste management and method to manage solid waste management. Okay, so what is solid waste management? And solid waste management is the municipal waste, industrial waste or hazardous waste, and that has to be managed properly, otherwise it will create a lot of dirtiness, right? So how it can be discarded, all those things. Okay, it can differ from the how it is to be handled differs if it is residential waste or industrial waste, because industrial waste will have the toxic chemicals that has to be handled separately. Okay, so if you don't handle that, what happens is the land, sea and air all will get polluted. Okay, so functions of solid management are waste minimization, recycling the waste, and waste processing with the recovery of resources, and waste transformation without recovery of the resources, and disposal on landfilling. Okay, so all the waste will be sent back to the land, so that it will be used for the organic purposes. Okay, so next question is the explain temperature and sound controls in building. Okay, sound control means how is sound controlled in building. So acoustic control of buildings is the science of controlling the unwanted noise in the living environment. Okay, means if somewhere outside some neighbor is fighting, we will not be able to hear inside the room. That is done by noise cancellation. Okay, so the controlling the noise in a building can be achieved by using absorptive materials within the building to reduce reflected sounds. Okay, so the type of material used to build the walls and the doors will be of very importance. Why? Because it will be playing an important role in cancelling out the noise which is not wanted. Okay, so importance of noise control: excessive workplace noise have several adverse outcomes such as decreased productivity, more difficult communication, permanent hearing loss, and increased health issues and all. Okay, so to avoid that, we'll be using soundproofing glasses. Okay, so, enhancing architecture acoustic with insulation includes noise control in partition walls, sound absorptive insulation for suspended system ceiling systems, reduce sound transmission, absorb the reflected sounds, acoustic insulation boards. Okay, that is how the sound is controlled. Next is the temperature control in building. To regulate the temperature, we'll be using HVAC. HVAC is heating, ventilation, and air conditioning. By using HVAC, the more than 60% of energy consumption in the building, that will be regulated. Okay, so the regulation of the temperature based on the requirement is very important, when it's to be heated, when it is to be cooled, so that proper heating, ventilation and air conditioning system should be installed in the building. Okay, and different types of weather will be there which will require different types of temperatures, so that is also a thing which is to be considered. Okay, so the components of a climate model include atmosphere, ocean, sea, ice, land surface, marine biology, and ice sheets. All of these contribute to uh, deciding what temperature is to be set inside the building. Okay, The next important question is, what is urban flood control? Explain the causes and remedial measures of urban control. Okay, so urban flooding is nothing but in a city, if the flood comes, that is called as urban flooding, caused by the rainfall overwhelming capacity of the drainage system, such as storm sewers. Okay, so what are the causes of the urban flood? First is the global change due to global warming. Second is urbanization, inadequate urban planning and infrastructure, planning a city very poorly so that if something less also comes, it will cause a major effect. Improper and inadequate drainage systems. If drainage system is not fine, when rain comes more, what happens? Drainage comes out. In the city, everything they will be dirty. Okay, improper waste management, that will also lead to the same outcome. So the remedial measures to control urban flood: proper maintenance of existing infrastructures, individual flood proofing measures, proper surveys, land use planning controls, and building development controls. Okay, by using these methods we can control the urban floods. Moving on to the next important question, we have, what are energy efficient buildings, and write a short note on security systems. Okay, this is also similar to the previous question, but here we have the energy efficient building. Okay, energy efficient building is the building which uses the least energy. Okay, to reduce the loss of energy and loss of heat through the building envelope. So it balances all the aspects of energy in use by providing an optimized mix of passive solar design strategies and energy efficient equipment and renewable sources of energy. By using these things, the energy used by the building will be very less, and it creates a comfortable living condition inside the dwelling with least possible amount of energy consumption, maximizing efficiency in the use of resources. Okay, so energy efficiency is the use of less energy in the building to provide the same operation. Okay, so there are the ways in which we use the renewable energies and so on to achieve that. And this will help to manage the operating cost and provide better delivery of the system to customers while reducing environmental impact and mitigation risk. That are advantages of it. Okay, so what is recycling? Recycling we can use for providing efficient buildings. So what happens? A lot of waste gets produced from the people living in the building, right? So if all of those waste gets recycled, that will be of much more energy efficient, right? So it reduces the amount of waste sent to the landfills and incinerators. It also sells natural resources like timber, water, and minerals. It prevents the pollution and reduces greenhouse gases if we do the recycling. Due to recycling, it reduces the energy consumption for new materials because we are reusing the old materials itself. Many building components and construction debris can be recycled. Okay, so recycling plays a major role in energy efficiency. Okay, there are three methods for the waste recycling. First is site separation. Here each multiple boxes will be there which will be having one things inside that. Okay, different types of waste. And second is commingled recycling. Here there will be no separate tasks, but it sorts everything off site. Okay, makes it easier for the field staff to manage waste on site. Third is hybrid, which is a combination of both of these. For example, the one box for wood, one box for concrete, one box for non-recyclable waste, and so on. So it sorts the waste and handles it accordingly. Recycles also. Okay. Moving on to the module 3, we have a lot of theorems and the numericals that were the most important questions from module 3. Let's have a look. The first one is define force and explain the classification of forces. Okay, what is a force? It is an action exerted by one body on the another body. Okay, one body on another body. What is the force exerted? The action is called as the force. Okay, it tends to change the state of the from the rest to the motion of the body. Okay, it is a vector quantity and it has both magnitude and direction. This SI unit is Newton for the force. Okay, so system of forces, you have to this also is an important concept. The system of forces, different types of forces. Classification is coplanar forces and non-coplanar forces. In coplanar we have four: collinear, concurrent, parallel, and non-concurrent. And in non-coplanar we have three: concurrent, parallel, and non-concurrent. Okay, so the differences between each of these. Okay, first is coplanar forces. It consists of forces which have lines of action in the same plane. As you can see, this is in the same plane, xy plane. Okay, all of the forces are in the same, so that is a coplanar force. Non-coplanar, it will be in different planes. Coplanar collinear forces. In coplanar collinear forces, it will be in the same line of action. Okay, means in a tug of war, tug of war there will be one force here and another force will be here, right? It will be in the same line of action. That is coplanar collinear force. Coplanar concurrent force, all the forces in the same plane meet at the single common point. From all the different direction, it is meeting at a single point, that is coplanar concurrent force. Example, force acting on the hub of the bicycle. Okay, next one is coplanar parallel forces. These are the parallel forces in a single plane. Okay, so the system of forces acting on a beam subjected to vertical load. Okay, when a vertical load is lifted, at that time the forces direction is in the same. Okay, and it is parallel. And coplanar non-concurrent forces. Okay, these are the coplanar means in the same plane. Non-concurrent means they do not meet at the same point. Non-coplanar concurrent forces, there are in different planes but they meet at the same point. Example is tripod carrying a camera. Those are in three different planes but they meet at the same point. Non-coplanar parallel forces in different planes, it is having parallel forces. Okay, weight of a desk in a classroom. Okay, so a desk will be right side, so it is different planes. This one is all in different planes but they have parallel forces. Okay, next one is non-coplanar non-concurrent forces. They are neither in the same plane nor in the same point they are meeting. Forces acting on a moving bus. In moving bus there will be many forces acting which are neither parallel nor in the same plane. Okay, the next supermarket question, derive law of parallelogram of forces or the parallelogram law. Okay, first we'll have a look what is the parallelogram law. So, if two forces are represented in the magnitude and the direction by the two adjacent sides in a parallelogram, their resultant is represented in the magnitude and direction by the diagonal of the parallelogram drawn from their common point. What it means is, if there is a parallelogram like this, okay, parallelogram is ADCB, okay, or ABCD. This is a parallelogram. Now, the angle between this one and this one is theta, okay. And if I draw a diagonal R here, I can calculate what is the force acting by using R and theta. Just by using r and theta and the values of q and p, I can calculate the value of it. Okay, so how we can calculate the value? That derivation we have to do. Okay, so I'll tell you what the derivation you have to do is, construct a similar triangle here with right angle at the point E, and this angle will also be theta because they are the same parallel lines. QAB and DC are parallel, so this angle will also be same here. So what we'll be first doing is, we will be calculating DE. Okay, what is DE? DE is nothing but q cos theta, right? Cos theta is what? Cos theta is de by q, so d will be equal to q cos theta. Similarly, ec will be q sin theta, right? So this is q sin theta, this is q cos theta, and this is p value, right? So this is p plus q cos theta, this whole thing. Okay, this whole thing is what? P plus q cos theta, and this one is q sin theta. Now this is also a right angle triangle, right? So the r will be equal to r square by Pythagoras theorem will be equal to this whole thing, which is p plus q cos theta whole square plus this value, which is q sin theta whole square, right? When we do this and we will be simplifying it, we will be getting the value of the force acting on it. Okay, let me show you that. So this is the same things which is written here, which I have explained. You can go through it. Okay, so we'll be getting the value of r square. R we will getting as p square plus q square plus 2pq cos theta. Okay, this is the thing which we will be getting. R value we will be getting. Okay, R is the resultant force. So in ACE, the theta value we have to calculate. So we can take tan theta, which is CE by AE, which is q sin theta by p plus cos theta, and the value of theta will be tan inverse of q sin theta by p plus q cos theta. Okay, so theta value also we got. R value is the resultant force also we have got. Okay. So this is the things you need to write for the derivation. Next is, find the resultant of the three forces acting on the point O. Practice all problems related to resultant force. Okay, this is one of the type of the question, repeated question which can be asked. So you have to practice this type of question many more. Okay, so I'll be explaining you what is the concept used here. Okay, see, there is two components of the forces. If any force is present here, okay, suppose that this is one force. Okay, this force will have an x component which is called as f of x, and this will be having a y component which is called as f of y. Okay, this will be having two components. This is y direction, this is x direction. Okay, so the first one we will calculate f of x in all directions, and for f of y in all directions we will consider these both separately. If f is given, we have to calculate f of x and f of y. Okay, so like that, in this case three forces are given. This is one force of 10 newton, this is another force of 15 newton, this is another force of 25 newton. Now how do we calculate the f of x values? So suppose that, take this. Okay, 25 newton is here. Okay, now 30 degrees here. Now what is the value of this line which I have marked at the last? Okay, this line value, what it is? This line value will be 25 cos 30. Okay, because see, what is cos 30? First let me take this diagram separate here. Okay, I'll be explaining this for this question. Rest all will, they will be the same thing only. Okay, 30, let's mark it as A, B and C. Okay, now see, This is 90 degree, right? What is cos 30? Cos 30 is AC by BC. Okay, C is not here, C is here. AC by BC, sorry, BC by AB, right? Cos theta will be equal to BC by AB. Okay, so what is BC? BC will be equal to AB cos theta, right? What is AB? AB is nothing but this one. This value is 25, right? This value is 25. So it will be 25 cos theta, which is nothing but f of x. Okay, this value we got as 25 cos 30. Like that we will take. Okay, 25 cos 30, and this is 25 sin 30. This is 10 cos 60, and this is 10 sin 60, and this is for 15 cos for 15 sin 45, this 15 cos 45, like that. Okay, so first we'll take consider all the x-axis. Okay, f of x will be equal to 25 cos 30, which is this value, minus 10 cos 60, because in the negative direction, negative this is, so minus 10 cos 60 plus 15 cos 45. 15 cos 45 is in the positive direction, this is negative direction, and this is positive direction. Okay, so accordingly we have to take it. Now we apply the values of cos values and calculate, we'll get the f of x value. Same thing we'll do for the f of y value and find out the f of y value. Resultant will be f of x square plus f of y square is root. Okay, so r will be equal to this one. Theta will be equal to tan inverse of f of y by f of x. Okay, f of y we have got, f of x we have got. Divide them and take tan inverse, you'll be getting theta value. Okay, so we got the theta value and we got the individual resultant forces. That's the same thing they had asked. Okay, resultant means r value have to calculate. Finally, r value have to calculate. So we've got both of these answers. Okay. Next is state and prove Varignons theorem. Okay, what is Varignons theorem? It states that moments at each point will be, see, if there is a diagram like this, and there are two forces. Okay, this is F1, this is F2. Okay, and moment is what? Moment is nothing but the distance, okay, multiplied by force. Okay, distance multiplied by force is called as a moment. For example, if there is a object like this, okay, and it is swinging like this. Now if I have a wall here, okay, now if this object hits here, what will be the moment? If I want to calculate, that will be equal to what is the force acting on it multiplied by what is the distance present here. Okay, F into D, that will be the moment. Okay, moment is equal to force into distance. Okay, so that will be the moment. So in this case, what we will be considering is two forces, F1 and F2, and the resultant force will be R. Now what this theorem says is that the moment of F1 plus the moment of F2 is equal to the moment of R. That one is the thing which we have to prove. Okay, so F1 is here, F2 is here, and the values is theta 1 for F1 with the x-axis, and F2 is theta 2 with the x-axis, R is theta with the x-axis. Okay, so the value of the moment of F1 F2 will calculate, and then we'll add up, and then that will be equivalent to the moment of R. Okay, so basically the D value, what is the D value? D is the force which is acting. Okay, the force which is acting is OA cos theta 1. Okay, see, cos theta 1 will be equal to the value of this one, this whole thing, OA, right? This will be equal OA cos theta 1. When we do, we'll be getting the value of the force. Okay, sorry, not force, distance values will be getting. Okay, distance D1 D2 and D. Okay, D1 D2 and D is nothing but this is D2, this is D, and this is D1. Okay, the perpendicular value from here to here, that is the D value. Okay, so that is the distance we are calculating. Okay, distance, and we have to calculate the one is distance, another is force. Okay, fine. Distance is OA cos theta 1, OA cos theta 2, and this is for cos theta. This is for F1, F2, and R. This one thing you have tried. Now moment will calculate. Moment is nothing but the force into distance. Force here is R. Okay, the final force is taken as R. So R into OA cos theta. Okay, so OA R cos theta will be the moment of R about A, the resultant one. Okay, this is the resultant one. It will be OA cos theta, R OA cos theta. Next, X component of the resultant is, this is the MR value, right? So X component will be R cos theta, okay, which is Rx. Next is the y axis will be R sin theta. Okay, this is x component. Like that we'll calculate the y component also. So x component for R we have calculated. Next we have calculate the x component for F1. F1 will be equal to F1 into D1, F1 into OA cos theta 1. So OA will be taken here, and F1 cos theta 1. This is the moment of F1 about A. X axis means we will be calculating F1 cos theta. Okay, so F1 of x, M1 is equal to OA into F1 of x. F2 will also be same, M2 into F of M2 is equal to OA into F2 of x. If we add both of these values, OA F1 of x, OA F2x. If we add both of them, we'll get OA F1x plus F2x. Okay, but f1x into f2x is equal to r of x. Why? Because it is the sum of the resultant components. See, result will be equal to the summation of the individual forces, right? So individual forces of f1 and f2 are f1x, f2x. So rx will be equal to f1x plus f2x only, obviously. So we can substitute f1x plus f2x as r1x, sorry, rx. Okay, so if you put it as rx, you'll be getting this value equivalent to mr. See, this value is same as equation 1, oa into rx, right? Equation 1 was what? oa into rx, that is mr. So m1 plus m2 is equal to mr. That denotes that the summation of the individual forces moments is equal to the resultant's moment. Okay, that is the Varignons theorem. Moving on, we have the next one, which is state and prove Lami's theorem. In Lami's theorem, if three coplanar forces are there, three forces, let's consider it as P, Q, and R. This is P, this is Q, this is R, meeting at a single point. That's why it is coplanar. Okay. In that case, the angle formed here are alpha, beta, and gamma. Okay. In that case, the value of Q will be equal to the sine of this angle. Value of R will be equal to the sine of this angle, and value of P will be equal to the sine of this angle. Okay, that is the theorem. At the point of equilibrium, then each force is proportional to the sine of the angle between the two other forces. Okay, that is the Lami's theorem. Now we have to prove the Lami's theorem. So basically, P by sine alpha is equal to Q by sine beta is equal to R by sine gamma. Okay, so to prove that, we have to make one a diagram like this. Okay, in this diagram, this is R, this is P, this is Q. Okay, and this is beta, this is alpha, this is gamma, and we are divided into two parts here, and this the point. The point here is C. Okay, now what we will be doing is, from the triangle AOC. Okay, we will consider a triangle AOC. Okay, AOC. This angle is nothing but 180 minus beta. Okay, that you understand, right? See, this whole angle is 180 degree, right? If we subtract beta, will be remaining with this. So this angle is nothing but 180 minus beta. Okay, so ACO is equal to BOC is equal to 180 minus beta. What is BOC? BOC is BOC. This angle and this angle both are same. That is equal to 180 minus alpha. Sorry, 180 minus beta. So BOC will be similarly 180 minus alpha. Okay, ACO, ACO. Okay, this angle and this angle will be same. Opposite interior angles will be same. So this is 180 minus alpha. So this will be also 180 minus alpha. So we have got two angles here. First one is this one, 180 minus beta. This is 180 minus alpha. Okay, and the summation of the angles in a triangle is equal to 180. So 180 degree is equal to 180 minus alpha plus 180 minus beta. Okay, and this angle, which is this angle, OAC or CAO. Okay, plus CAO. Okay, now when we do this one, that should be equal to 180, right? So what we'll be doing is, see, 180 will become 360. When you take 360 here, what it will become, 180 minus 360, that will be equal to minus 180. So minus 180 will be equal to minus alpha plus beta. Okay, 180 minus beta, right? So this will be 180 minus beta. Okay, minus alpha minus beta plus CAO. Okay, now what is CAO angle? That let's have a look. Okay, CAO is equal to 180 minus ACO plus AO. So basically we have to calculate CAO. CAO we have to calculate. Okay, so what we had got here, minus 360 is equal to, sorry, minus 180 is equal to minus alpha minus beta plus CAO. If we shift all of this into this side, what we'll be getting is alpha plus beta minus 180 is equal to CAO. Okay, this angle is equal to alpha plus beta minus 180 degree. Okay, so alpha plus beta minus 180 degree CAO will be getting. But we know that alpha plus beta plus gamma is equal to 360 degree, right? Alpha plus beta plus gamma is 360 degree. So if this is equal to 360 degree, alpha plus beta will be equal to 360 minus gamma, right? Alpha plus beta will be equal to 360 minus gamma. So what we'll be doing, both the sides will subtract with 180 degree, minus 180 here and minus 180 here. So when we do that, we'll be getting 180 minus, and we'll be shifting gamma here. Okay, 180 minus gamma will be equal to alpha plus beta minus 180. Okay, and this one is equivalent to this one, right? CAO. So CAO became 180 minus gamma, right? CAO become what? 180 minus gamma, right? This is the 3. So CAO is this one. This is the value of CAO. So applying the sine rule states that OA by sine ACO. Okay, what is the sine rule? OA by sine ACO. Okay, let's have a look. OA by sine ACO. OA by sine ACO. Okay, see, OA by sine of this angle. OA by sine of this angle is equivalent to BQ by sine of this angle. Okay, that is equivalent to another value here. Okay, see, so there are three things are there: AC by sine AOC and OC by sine CA. Okay, so these three things are there, and ACO value is 180 minus alpha, AOC is 180 minus beta, CO is 180 minus gamma. Now we have got this ones 180 minus alpha, it is same as sine alpha only, right? The sine 180 minus pi is equal to, sorry, sine pi minus x is equal to sine x, right? So sine 180 minus alpha is equal to sine alpha only, and this will also be sine beta, and this will be sine gamma. So basically p by sine alpha is equal to q by sine beta is equal to r by sine gamma. Okay, so this is the proof you need to write for Lami's theorem. Okay, now the questions can be asked with related to Lami's theorem. Let's have a look at one of the question. Okay, so there are 2 points here. This is point B and this is point C on which the forces are acting. This is taken as separate diagram and this is taken as separate diagram. Okay, so we'll be solving them. Now see, if we take this as separate diagram, free body diagram of B and free body diagram of C. Okay, first let's start from C. If you apply the Lami's theorem, TBC, okay, this is TBC and this angle is 60 plus 90, this is right angle, so 60 plus 90 is 150. So TBC by sine 150, okay, TBC by sine 150 is equal to TCD by 30 plus 90 is 120. So TCD by sine 120, and here the remaining angle will be 90 degree, so 800 by 90 degree. These all are equal. When we equate them, we will be able to find out the value of TBC and TCD. We will be using these two values to substitute it in this equation. F of x is 0 in the case of this diagram. We have TBC we have calculated. We will substitute the value of TBC here. So minus TAB cos theta, that is equal to f of x here, plus TBC cos 30, which is the f of x here, that is equal to 0, because this and this should be cancelling each other, so this value will be 0. We have the value of TBC, we can calculate the value of TAB. Once you calculate the value of TAB, same thing we will do for the Fy also. The top forces, here it will be TAB sin theta, here it will be TBC sin 30, here it will be 1000 in the negative direction, so minus 1000. So when you do this one and we'll calculate, we'll get the value of TAB sin theta as 1200. We have the value of TAB sin theta and TAB cos theta. We'll subtract, means divide it, so that TAB gets cancelled, so it will be 1200 divided by 346.41. So we'll easily able to calculate the sin of value of theta by taking the tan inverse. Once you got the value of theta, we can calculate all the other forces values like TAB also, which is remaining. We can calculate using the values, right? Theta value if we have, we can easily calculate the value of TAB. Okay, so that is how we will calculate the values of all the things. Okay, see, TAB is present here. If we divide 346.41 divided by cos of 73.89, we will get the value of TAB. Okay, like that we will calculate all the forces and the angles mentioned in the question. Okay, this is how we will apply the Lami's theorem. Next is basic idealization of engineering mechanics. So some definitions. Okay, what is concept of idealization? It is used in mechanics to simplify practical problems without appreciable loss of accuracy. Okay, so following idealizations are used in the mechanical. First one is particle. What is a particle? It may be defined as an object as only a mass but no dimension. That's particle. Example: continuum. Body is made up of several particles. There are particles that can be further subdivided into a molecule, atoms, etc. Next is rigid body. A body which does not undergo deformation. Okay, that is a rigid body which does not change its size or shape on application of external force, that is rigid body. Okay, and if see, this is the body, and if force is applied and the shape is not changing, that is called as rigid body. Okay, these are the idealizations of the engineering, civil engineering. Okay, moving on to the module 4, we have practice the theorems. We have to be well, we should be uh, expert enough to solve the problems as well. Okay, so we'll have a look at the theorems and the problems. Okay, important theorems and problems. Okay, so derive an expression to further locating the centroid of a rectangle. Okay, so this is the rectangle which is given A, B, C and D. Okay, this is the rectangle which is given. You have to calculate the we have to locate the centroid. Okay, centroid means the center point of the rectangle we have to locate. So how do we do that? Okay, so the first thing, AB is taken as B. Okay, so AB is taken as B here. Okay, Okay, see, this value is taken as b. Okay, and this value is taken as d. This small component here is dy, and this value from AB to the strip which is being taken into consideration is y. Okay, now this is a rectangle lamina. First we'll calculate moment of area elementary to the strip about AB. Okay, so we'll calculate the moment of elementary area about the strip AB. So what is the formula? Area into perpendicular distance. Area of the this strip we are calculating. Okay, for this strip what is the area? Area is nothing but width into height. That will be equal to b into dy. Okay, b into dy multiplied by perpendicular distance, that is y. With respect to AB we are taking the moment of the strip, so the perpendicular distance is y here. So multiplying will be getting the moment of strip about AB. Now we will be extending it, integrating it from 0 to d. Okay, so we'll find out the integration of this moment, so we'll get the moment of the whole area, which is bd square by 2. Okay, this we got by integrating the small strip. Okay, similarly, what we'll be doing is the moment of total area will calculate directly BD into y bar. Okay, y bar is nothing but the perpendicular distance till the centroid. Okay, till the centroid, what is the perpendicular distance? That moment we'll be taking. Okay, so BD into y bar. Okay, so basically BD into y bar should be equivalent to this. By that we'll get the value of y bar, that is equal to d by 2. By considering vertical strip, we can do the same thing and get the value of x bar also. These are the distances of the centroid, d by 2 and x is b by 2. Okay, that's all. Next one is the same thing we'll derive for the locating the centroid of a triangle. For the rectangle it was a bit simpler. For the triangle you have to consider two triangles. Okay, one is this triangle. Okay, and another one is this triangle. Okay, so the steps will be as follows. Okay, first, using the property of similar triangles, we have b1 by b is equal to d minus y by d. Okay, b1 by b, b1 by b. Okay, this by this is equal to d minus y, this by this. Okay, for two triangles similar, the similar triangles property. So we'll get the value of b1, and once we have the value of b1 we can calculate the area of the elementary strip. This area we can calculate by b1 into dy. Okay, so b1's value we have got. Now we'll integrate it. After integrating it to the whole sum 0 to d, you'll be able to calculate the sum of the moments of the elementary strip to the whole area. Now the moment of whole area is half into base into height, right? So half into base into height will be this one, and taking the centroid here as y bar. Okay, because we are calculating the moment, so we have to include the distance also, so it will be y bar. Now this value will be equal to this value, so we'll find out the value of y bar, which is d by 3. So x bar also, x bar we are not calculating. Okay, here only the y bar is taken into consideration. Okay, this is for the centroid of triangle. Same thing we'll be doing for the centroid of semicircle and quarter circle as well. Okay, so you can go through this concept here. I'll not be going into the depth because it will become very much complex. So basically the same thing is happening. We are considering one strip here, calculating the moment, integrating it, and then we are equating it with the whole semicircle or the quarter circle separately, and we'll get the value of y bar and x bar. Okay, so moment of elementary strip about the y-axis is half pi r square, half r square d theta, not pi r square, half r square d theta. Okay, into 2 by 3 r cos theta. Okay, so this is the value which we'll be having for the strip, and we'll be integrating it with respect to minus 92 plus 90 for the semicircle, and we'll be getting a value. This is for the whole area, and this is equivalent to pi r square by 2 into x bar, the moment of the whole area about the y-axis, same as the previous two diagrams we have done, right? We'll equate this, find out the x bar value. Same thing you have to do for the quarter circle also. You can go through it and we'll get the x bar value. Okay, done. Next is determine the position of a centroid for the lamina for the shaded portion. Okay, so question can be asked like this also. Here in this whole diagram, they will be giving you just the diagram. You have to divide into different parts. So this will be one part. Okay, this will be rectangle, this will be triangle, and this will be a semicircle. Applying the formulas for each of these, calculate the moments and adding it up. Okay, that's all what you have to do. So rectangle, what is the area? 120 into 100. This is 120, this is 100. So total area is 120 into 100. X will be x by 2. That is the standard formula, right? X by 2 and y by 2 for a rectangle. We have just calculated in the above questions. We have got the value of x bar and y bar. That is x by 2 and y by 2. So that will be equal to 120 by 2 and 100 by 2. So these two values we have got. Ax is nothing but area into x, and area into y is ay. We'll calculate and keep. Same thing do for the semicircle also. Find out the area, find out the x values. These values we have taken from the formula which we have derived at the top, and we'll be finding out the x and y values, and then we'll be writing ax and ay. Like that we'll do for the triangle and the circle, for all the shapes which are formed from the diagram. And after that we'll be finding out the whole sum for ax and ay also. So x bar will be summation of ax by a, y bar will be summation of ay by y. We will get two answers. This is the x bar and y bar values. Okay. Moving on to the next super important question, we have write a short note on the centroid, center of gravity, moment of area, centroidal axis, and axis of symmetry. So some definitions are there. What is centroid? It is the point where the whole area of the plane figure is assumed to be concentrated. Okay, so if this is the area, the whole area is supposed to be concentrated at this point, x bar and y bar from the x and y axis. Okay, what is center of gravity? It is the point where it is assumed that all the body's weight is concentrated. Okay, so to balance like that. Okay, what is the area axis of reference? The center of gravity of the bodies is always calculated with reference to some assumed axis known as axis of reference. Okay, next is moment of area. Okay, moment of area is nothing but we'll consider a strip. Okay, and we'll be calculating the area, and then we'll be integrating it to find out the whole area. That is called as the moment of an area. Okay, moment of the whole area. Next is centroidal axis. Axis passing to the centroid is called as centroidal axis. Okay, and what is axis of symmetry? If we divide an object into two parts and it is symmetrical, that is the axis of symmetry. This is vertical symmetry and this is horizontal symmetry. Okay, moving on to the module 5, we have the first experiment question. Determine the moment of inertia. Here moment of inertia is the main thing. Okay, of the rectangle with width b and the depth d, about its horizontal centroid of axis with axis and vertical centroid of axis. So with respect to two axes, we have to calculate. First is horizontal, second is vertical. You have to calculate what? Moment of inertia. So let's have a look. This is the diagram given. This is d by 2 divided into two parts, and this is dy and this is y, and the whole value of this is d, and breadth is width is b. Okay. So consider a small area. This is the strip area. Find out the area of it. dA will be b into dy. Moment of the strip, elementary strip about x-axis will be equal to area into distance. That will be dA into y, which is b dy into y. Then next we'll calculate the moment of inertia about the x-axis. Moment of inertia will be the value of the distance. I mean the area into y square. Y is the distance square. We have to take the square if we are calculating the moment of inertia. Now we have the moment about it and moment of inertia also. We will find out the summation of whole area. How we will summate the whole area? We will be just taking the integral of the moment of inertia of the elemental strip. This is the moment of inertia for a strip. To calculate the moment of inertia for the whole figure, we will have to integrate it with the limits minus d by 2 to d by 2. Okay, and in do that we will be getting the moment of inertia for the x-axis, and similarly for the y-axis also it will be like this. Okay, this much thing you have to write. Okay, next is determine the moment of triangle. For triangle also the same thing you need to do. Okay, this all you have to write and practice. Two triangles are taken into consideration. One is this triangle and second is this triangle. For first we'll calculate for the small strip here. Okay, there is by the similarity criteria we can find the value of L, area of the small strip, moment of the small strip, moment of inertia for the small strip, summation for the whole triangle. We'll get the I value for the whole figure. Okay, like that we'll be doing it for the smaller triangle also. We'll be getting another value here, I of x. Okay, so once we have got the values, that will be the final answer. Okay, same thing goes for the inertia of circle, semicircle, and quarter circle. You can go through it. The small area which is considered is r into this value. Okay, this is the r d theta. Okay, r into r d theta is the small strip considered, and we'll be applying the same formulas here for a strip, then for moment of inertia for the x-axis, then for the whole area. Okay, so we'll get ixx and iyy. This you have to learn the derivation also, practice it 3 or 4 times, write it, and remember these formulas as well. This can be asked in the numericals also. Okay, this is for the semicircle. You can go through it, and this is for the quarter circle. Okay, everything is same. If you go through it carefully, you'll be able to understand. Okay, so the next super important theorem from the module 5 is explain the perpendicular axis and parallel axis theorem. Two theorems are there, perpendicular and parallel axis theorem. Very simple. Perpendicular axis theorem, let's consider. Here we'll be having the xyz values here, and xy will be here, and r will be here. Okay, now the summation of the forces will be present here. Okay, next izz will be equal to ixs plus iyy. That is the claim of the perpendicular axis theorem. It states that ixs and iyy are the moment of inertia about the mutually perpendicular axis. Then the moment of inertia about the z axis will be the summation of the both the axes, okay, x and y. So basically, if you want to find out the moment of inertia for this axis, it will be the summation of moment of inertia for this axis plus moment of inertia for this axis, okay. So this is the equivalent diagram given here also. This is x and this is y. This is x and this is y, and this is the z value, okay. Now to prove, x will be the perpendicular distance of the area OY, and y will be the perpendicular distance from the x-axis, and z will be the r will be the perpendicular distance from the z-axis, okay. Now moment of inertia about OX will be IXS, that is DAX y square. For the y-axis it will be DAX square, and for the z-axis it will be DAR, okay. Because r will be considering here, this is x, this is y, and the middle thing which you can see as z here, that is taken as r here, okay. So three moment of inertia we have taken here. Now from the triangle OAB, r square is equal to x square plus y square from OAB, okay. OAB, okay. If we are taking this as r here, r square will be equal to x square plus y square, that is Pythagoras theorem. So based on that, r square is equal to x square plus y square. We have the values of r is DAR, right? The summation is DAR. So IZZ will be dA into r. R can be substituted as x square plus y square, and when we will expand this, this will be dAx square plus DAy square. That is nothing but IXS plus IYY. Okay, this is the required proof which we had, which we needed to arrive at for the perpendicular axis theorem. Next is the parallel axis theorem. In parallel axis theorem, what happens? There will be a reference axis, okay, and there will be another shape here. From that shape, another point, another line will be going. This is the main axis, and this will be the it will be passing through the center of gravity, okay. And another strip will be considered here, and the distance till the strip is y, and the distance of the strip, the width of the strip is dy, okay. After making this thing, what you have to write is IAB is equal to IG plus AH square. H is the distance between reference axis and the main axis, and A is the area of the whole figure, and Ig is nothing but the moment of inertia of this axis which is passing through the center of gravity of that object, okay. So after what it says is the moment of inertia of the reference axis is equal to the moment of inertia of this axis plus AH square, okay. So these are the terms we will be writing it here. And finally, again the same thing we'll be doing. First we will take this strip and find out the moment of inertia, then we will find out the moment of inertia for the whole object. So once we got the moment of inertia for the whole object, then we'll be equating it with the moment of inertia for the whole object taken directly, okay. So once we'll arrive at an equation where we'll be having moment of elemental strip about AB. First we are calculating the moment of the strip individually, then we will calculate with respect to AB, okay. That will be equal to dA into H plus Y, where we are taking H plus Y with respect to this axis. When we are taking the moment of inertia for the strip's distance will be this y distance plus h distance, so it will be h plus y, and area will be equal to dA into dy. It will be dA only, right? That area can be taken as dA only. So dA is nothing but, we'll be keeping it as such and integrating it, okay. So that will be equal to IAB, and IAB will be equal to h square A when we do the integration, plus this whole thing can be taken as Ig plus 2h. 2h will be cancelled, so basically it will remain only IH. Ig will be equal to the IXX, okay. IXX is nothing but the moment of inertia about this axis, okay. So basically IAB will be equal to the moment of inertia with respect to this axis plus A into h square, okay. That is the same conclusion when we will be arriving when we take IAB separately, okay. Moving on, we have determined the moment of inertia for the unequal I section as shown in the figure about its centroidal axis. Okay, another very important question, moment of inertia we have to calculate for this diagram. So basically this is 300 meter, this is 200 millimeter, and this is 10 millimeter, this is 300 millimeter, this is 10 millimeter, and this width is also 10 millimeter. We'll consider three diagrams. This is first diagram, okay, this is second diagram, and this is third diagram. For each of these we'll calculate the value of moment of inertia, then we'll add it up. So what is the area of this strip? 10 into 200, okay. It's not written here, but this one is 200, okay, this whole thing. So 200 into 10, that is the area of 2000. Y1 is nothing but the distance from the center of this point, the center of gravity of this point, till the reference axis, which is a this down bottom part. So that will be equal to, if you observe carefully, this length is 10. So in a rectangle, the center of gravity, how we will calculate? The center of gravity will be equal to x by 2 and y by 2, right? So if this is 10, the center of gravity here will be 5 only, right? So it will 5 will be nothing but 10 by 2. Okay, so 10 by 2 will be taking it here, and plus 300. 300 is this distance. Okay, 300 plus 10. 10 is this width. Okay, so from the center of gravity of this object till the end point, what is the distance? That we will calculate as y1. Same thing we will do for the y2 and y3 as well. Calculate the average of it, and then we'll keep it here. Then we'll calculate the moment of inertia for the I section about x6, which is ix6. This will be the okay, so ix6 means this point will be taken into consideration, and from here we'll be calculating the moment of inertia. So the distances with respect to that axis, that will be ix6, and I2 axis and I3 axis. For three objects we'll calculate. Okay, this is the ix6 value. Okay, this is the ix6 line. From here, what is the moment of inertia for this diagram, for this diagram, for this diagram, for the diagram 1 2 3? So it will be ix1, ix2, ix3. That will be adding it up, so that we will get ix6 value. Okay, so ix6 will be i1x plus i2x plus i3x. We'll be calculating it individually. Okay, by taking the values, you can go through it. We'll be finding out the value of ix6 finally, and same thing we'll be doing after means for each object we'll be doing i1, i2 and i3, and then we'll be adding it up, so we'll get the value of ix6. Okay, this is the thing you need to do for finding out the value for horizontal axis. Okay, they had asked two questions, right? First is the horizontal axis, second is the vertical axis, right? So moment of inertia for the horizontal about its centroidal axis. For centroidal we need both horizontal and vertical. Okay, so horizontal we'll calculate like this ix6. Now iyy we have to calculate the same things we'll be repeating here also. Section 1, section 2 plus section 3 will be calculating, and we'll be adding it up. Okay, so we'll be considering this angle here. This is for the section 1. Okay, for the section 1, this is the yy we are considered here. The width is 10 and the length is 200 here. So we'll be calculating it from I11 is equal to IG1 plus A1 B1 square. Okay, so I11 Iy1 will be equal to dB cube by 12. This we had derived in the first equation, right? You remember, right? This directly will be applying this formula, and this is the value, which is A1 H1 square. Okay, A1 H1 square, H will be 0, so this value will get cut off. So this value will be 10 into 200 cube by 12. So this will be the I11 YY value. Similarly, we'll do for the I22 YY value and I3 YY value. When we'll do that, we'll add it up and we'll get the final answer here. Okay, so X is stronger than Y, so X is it is stronger, the hold is stronger in the X direction. That one will be considered. So basically what it says, if we balance it, this diagram, if we balance it from the x-axis, or if we balance in the y-axis, which is stronger. Okay, same things, whatever is done for the x-axis is also done for the y-axis. If you go through the steps carefully, you'll get to understand. Okay, so this is the thing, and this diagram which is present here, as you can see, this is taken from here. Okay, this is this part of the diagram. I'll just highlight it. So this part of the diagram, right? This part of the diagram is taken. Okay, this is 200 and this is 10, and this is the y axis. Okay, and this is just taken for the first diagram. Okay, if I draw it more clearly, this part is taken. Okay, this part is taken and it is drawn like this, and it is taken like this. The boundary is here, and this value which is here, that is taken from here, and this is 10, and this is 200, right? So it is written as 200. Then whatever steps we had followed here, finding out a1 y1 and everything, that is also happening in this case as well. Okay, this is yy instead of xx, this is yy here. Okay, so if you go through the steps and calculation, you'll get to know what is happening. Okay, so like that we'll conclude it, whichever is stronger. Okay, that's all for the super important questions of the civil, and don't miss any of these questions. These are the most repeated super important questions. Solve all of them and you can easily score more than 80% marks. And before going, please do like and subscribe. It helps me make more videos like this, and thank you so much for watching. I'll see you in the next.